everyone. Today we're going to start talking about some things that we need to review from Algebra 1 as we prepare to learn to solve quadratic equations. The first thing that we want to talk about is factoring out a greatest common factor. And the steps to do that are to look at the coefficient or the number in front of each term and find the greatest common factor for those. And then secondly, look at each variable or letter separately and see if there is a greatest common factor between those as well. There is one thing that you need to remember about exponent rules, and that is when you divide variables that have exponents, you subtract their exponents. So let's look at a quick example here. If we have x to the 5th power divided by x to the 2nd power, subtracting the exponents, we have 5 minus 2, and that's equal to 3. So we get x to the 3rd power. So let's keep that in mind as we go through these. The first example is 5x plus 15. So remember that we want to look at the numbers first, and I see a 5 and a 15. What do those have in common? What is the biggest number that they have in common? And 5 divides into 15, so 5 is going to be my greatest common factor. In order to bring that out, what I want to do is basically undistribute it. So when we distribute something, we multiply it. So when we undistribute or pull it out as a greatest common factor, we divide it. So I'm going to divide both of these by 5. And so that 5 is going to come out to the outside of my parentheses, and I'm going to be left with, let's see, 5x divided by 5 leaves me an x, and 15 divided by 5 leaves me with 3. So my expression with the greatest common factor of 5 pulled out is 5 times x plus 3. Let's look at another example. This time we have 5x squared plus 10x. I can see right away that I have numbers and letters in both of my pieces, and so I need to consider both. 5 and 10 have a common factor of 5 because 5 will divide into both 5 and 10. And then if we look at the x's, we have x squared in the first term and an x in the second term. We could rewrite x squared as x times x, and then of course this is just 1x. So how many do they have in common? I can say that each of them has at least one x. The first term has 2, but the number that they have in common is 1. So I'm going to divide everything by 5x. And bringing that out to the front, I will have 5x multiplied by x plus 2. Because 5x squared divided by 5x is going to leave me with an x. 10x divided by 5x leaves me with 2. Continuing to look at our next example, this one has 3 terms, but we treat it just the same. We look at each of the pieces individually. First, I'm going to look at the numbers, the coefficients that are in front of each variable. And the greatest common factor between those, I have a 2, a negative 10, and a 20, and 2 will divide evenly into each of those. If I look at x to the 3rd, x squared, and an x, the greatest number of x's that they have in common is just a single x. The first and second terms have more than one, but since that third term only has one single x, that's how many I can take out. So I'm going to divide everything by 2x, which comes out to the front. And when I pull that out, I have 2x to the 3rd divided by 2x. Remember to subtract your exponents, 3 minus 1. That's going to give me an x squared. X squared divided by x, and I have that negative 10 over 2. I'm going to have negative 5 over an x, just a single x because 2 minus 1 is 1. And then finally, 20x divided by 2x is going to give me a plus 10. The x's, there's one on top and bottom, so those go to 1 and cancel out. Let's look at another example. In this example, we have 3x to the 4th minus 12x to the 3rd plus 6x squared. Again, I'm going to look for a greatest common factor between my numbers first, and I see a 3. And between my x's, the smallest exponent that I see is an x squared, so that's how many they have in common. I'm dividing everything by 3x squared. All right, so pulling out the 3x squared to the front, what I have left is x squared, because 4 minus 2 is a 2. I have minus 4 and x to the third over x squared. 3 minus 2 is a 1. And then finally, 6x squared divided by 3x squared is going to leave me with just a 2. I'd like for you to pause the video and try numbers 5 and 6, and then come back here and see how you did. All right, so you should have determined that the number that 4 and 10 have in common is a 2, and then we have an x squared and an x, so the number of x's that they have in common is just a single x. So we're dividing everything by 2x, and when we do that, we get 2x times 2x minus 5. Finally, on number 6, you should have determined that your greatest common factor was a 7 and an x, and dividing that out, you get this answer of 7x times x squared minus 4x plus 2.